is connected between these two terminals. I will call it as terminal A, and this terminal is the B terminal. Now here in this case, as per the Thevenin's theorem, step number 1, we have to remove the load resistance and redraw the same circuit. Second step is the calculation of the Thevenin's voltage, that is Vth. Third step is the calculation of the Rth. And finally, when we know the Vth and Rth, then complicated network will be replaced by the Thevenin's equivalent network. Here at the beginning the figure looks to be complicated, but not it is. The first, what we will do, I will find out the simple series and parallel combination, as well as I will remove this load resistance which is of the 50 ohm. Means how will be the case? The 10 ohm resistance is parallel with the 10. I will replace these two resistances by the single resistance, that is 10 is parallel with the 10, means 10 into 10 divided by 10 plus 10, that is 20. Means in this case this value is coming to be R1 into R2 divided by R1 plus R2, means this value is coming to be 5 ohm. This 5 ohm is in series with this 5 ohm resistance. Similarly, here the 5 ohm is in series with the 5. I will replace these two resistances by the single resistance, as well as these three resistances by the single resistance. We will redraw the circuit and then we will work out on the calculation here in this particular case. Now here first I will draw the figure and then I will discuss about the calculations. I will remove the load resistance, means here in this case here, this will be the terminal A, I will take name here, and this will be the terminal B, I will draw here. Now here in this case 1, 2, 3 resistances are replaced by the single resistance. I will draw somewhere here. This is replaced by the single resistance. I will discuss its value later on. Then here 1, 2 resistances, that is 5 ohm and 5 ohm, is replaced by another single resistance. I will draw somewhere here. Something it is like this. Then here everything will be the same. Here will be the battery which is of the 10 volt, and then here will be one resistance which is of the 2 ohm. Here is another resistance which is of the 2 ohm again. Now what I will do, I will draw this 4 ohm again as it is. This 4 ohm as it is. Now what I will do, 1, 2, these two resistances, it is drawn in the vertical fashion. That's why in place of this I will connect something this way. Means here will be the one resistance, because again we have to convert it star into delta, and delta to star conversions are required for the calculation of the Thevenin's resistance. For that purpose we need. Now here 5 plus 10 is parallel with the 10, its value is a 5. This 5 plus 5 is a 10, means here its resultant value is a 10 ohm. Similarly, this 5 is in series with this 5, means its resultant value is a 10 ohm as it is. Here I will place this value as it is, which is 2 ohm. Here this value is again which is 2 ohm. Its battery is of the 10 volt with positive and negative terminals. Here is its value which is 4 ohm. This value is 3 ohm and this value is 2 ohm as it is. We are not doing anything, just I am redrawing the same figure. Means here in this case these three resistances are replaced by the single resistance having its 10 ohm value, and here these two resistances are replaced by the single resistance having its 10 ohm value. Now here in this case this resistance, it is drawn in this fashion, this resistance drawn in this fashion to have an equivalent circuit, and that's it. Now here in the second figure, now look at the number of loops. We have first loop, second loop and third loop, because here in this case, this is the step number 1. We are removing the load resistance and we are redrawing the same circuit. Now in the step number 2, we are planning to calculate its value of the Vth. We are interested in the Vth. For the calculation of the Vth, we have to travel from the B terminal towards the A terminal. Means we have to calculate voltage across 2 ohm, voltage across another 2 ohm, and voltage across this 10 ohm resistance. Means we need to calculate current in these 3 branches. We can use any path. We can use this path for that calculation, or we can use any path. But we have to travel from the B towards A. Now here, for that purpose, I will take this as loop number 1. I will take its current as I2. I have shown the direction of the current. This current is the I1. Here in this case I will take this current as I2, its value I will name, and finally current in this particular case I will take this current as I3. Now we have the two currents I1, I2, I3. We can use any method for the calculation of the current. Maybe the node analysis, maybe the mesh analysis, maybe the direct inspection method and so on. Here I am using the direct inspection method for the calculation of the current in the loops I1, I2, I3, and then we will calculate current in the 2 ohm resistors, this 2 ohm resistors, and finally in the 10 ohm resistors to calculate the value of the Vth. Now here in this case, if we are using the direct inspection method for the calculation of Vth, I am using the direct inspection method here. Now here will be the matrix, standard matrix format, something like this. We have the impedance matrix followed by the current matrix, which is equal to voltage matrix, or it is known as a constant matrix. Now here, how is the standard format for this particular matrix? The standard format for this particular matrix will be something like this. R11, R12, R13. This is R21, R22, and it is R23. Finally, R31, R32, and finally it is R33. This is the impedance matrix. Now first we will plan to calculate these values. What is the direct inspection method? In the direct inspection method, only the diagonal elements are positive. Remaining all elements are negative. Means here in this case the R11, R22 and R33 will be positive and remaining all elements will be the negative. Now here I am referring this figure. Now what is R11? Resistance which belongs to the loop number 1. Now here this complete is the loop number 1. How much is this resistance? This is 2 ohm plus 2 ohm, that is 4 ohm. 4 ohm plus 3, 4, 5, 6, 7, 7 plus 2, that is 9, 9 plus 10, 19 plus 10, 29. Means here 29 ohm is the value of the resistance which is R11. We did this. Now what is the value of R22? The resistance which belongs to the second loop. Now here resistance which belongs to the second loop is that is 4 plus 3, 7, 7 plus 2, that is 9. Means here the value of the R22 is the 9 ohm. We know this value. Then we will plan for the calculation of the R33. R33 is the resistance which belongs to the third loop. This is the third loop. That is 2 plus 2, which is 4, 4 plus 4, that is nothing but 8 ohm. Means here its value of the resistance, it is 8 ohm. Only the diagonal elements are positive, remaining all elements are negative. Now we are finding another two values at a time. R21, R12, because 12 is very same as 21. We are calculating these two values. Now what is the value? Resistance which is common for the first and second loop. Here is the first loop and this is the second loop, and the common resistances are the 2 ohm and 3 ohm. 2 ohm and 3 ohm, these two resistances are common for the first loop because this is the first loop. Look at the currents. In this branch, 2 currents are flowing. In this branch, 2 currents are flowing. In this branch also we have the 2 currents, but currents are different, I3 and I1. That's why it is common for the first and third loop. We are looking for first and second loop. First loop and second loop, common value is 2 and 3. That is 3 plus 2, which is 5. Means its value will be minus 5. This is minus 5 and this is also minus 5. Then we will find out the resistance which is common for first and third loop. Here it is the first loop and this is the third loop. Now look at this resistance is common for first and third loop. This resistance is common for the first and third loop. That's why its value will be, that is 2 plus 2, which is 4. Means its value is minus 4. This is minus 4. And here in this case also, this is also the minus 4 value. Now we are looking for the resistance which is common for third and second loop. Now this is third loop, or this is third loop here, and here is the second loop. For these two loops, common resistance is the 4. That's why its value will be, it is minus 4 and this is also minus 4. Now here if we know the values, then we are finding its currents, or we are naming its current to be exact. This is I1, this is I2, and here will be the I3. Now we will try to find out its constants. What are the constants? Now here if we are traveling with the direction of the current in the loop number 1, there is no battery, or there is no voltage source, or there is no EMF. That's why its constant will be 0 for loop number 1. Similarly for the loop number 2, if we are traveling in the direction of the current, then there is no battery or there is no voltage source. That's why its value will be again 0. if we are traveling for loop number 3 with the direction of the current, there is one source, and we are traveling from negative to positive, that is a plus, its value of the voltage, it is 10 volt. Now here we have the matrix, and from this matrix we can calculate its current, that is I1, I2 and I3. Now here I will use the calculator, and we are able to find out its current I1, I2 and I3. And by knowing these three currents, we are able to find out its potential. Now if I am using the calculator, now look at how to use the calculator, that also we are able to see here. If I am using this calculator, I will enter the values. Now here, just I will go to the mode. Here COMP, SD, then equation. I will enter 1. What are the unknowns? We have the unknowns as a 3. Enter the value of A1. A1 is this value, which is 29. I will enter this value, 29. I will put is equal to sign. Then it is minus 5 is equal to. Then minus 4, which is equal to. Then enter the value of the constant D1. Constant D1 is 0. I will enter its value as 0. For the second case, this is minus 5. This is minus 5. Then second value is 9. Then we have the next value is minus 4. Then constant D2 is 0 again. Then again we are entering the A3, which is minus 4. Then again minus 4. Then again its value is 8, which is equal to D3. And here value of the D3 is plus 10, which is equal to X is a 0.5. This current I1 is the 0.5 amperes. Now what is the value of I2? 1.21 amperes. This is 1.21 amperes. And what is the value of I3? The value of the I3 is 2.11. This is 2.11 amperes is the value of the current, which is I3. Now here, if we know the values of the currents I1 and I2 and I3, then we can find out its value of the Vth, that is Thevenin's equivalent voltage. Now look at how we are finding the value of the Vth. Now here, if we are finding the value of the Vth is equal to, I will take its modulus value, that is a positive value. We will travel from the B towards A, and while traveling we will use the potentials here. That's why this will be the plus sign, this will be the minus, this will be the plus sign, this will be the minus, this is plus sign and this is minus sign, because I am following the sign conventions of the I1. Now similarly, if I am following the sign conventions of the I2, this will be the plus, this is minus, this is I3, then this will be the plus and this will be the minus. These are the sign conventions. Now I will start from the terminal A, we will travel towards, start from the B, we will travel towards A. That is, we are traveling from positive to negative. I am following the sign conventions of the I1. Positive to negative, which is minus. Its resistance is 2 and its current is, it is I1 minus I2. Then we are traveling from positive to negative for the second resistance, which is again minus. Its resistance is 2 and its current is, it is I1 minus, it is I3. Then again positive to negative, which is minus, its resistance is 10 and its current is I1. That is 10 into I1. This is the value of the Vth, that is Thevenin's equivalent voltage. Now here, if we are substituting the values and if we are calculating the value of Vth, then after substitution its value is found to be, this will be, it is minus of minus, this will become plus, it will be 1.42. Then here its value will become the second term. This first term value will be this after substitution. The second value will be, it is 3.2, and this third value will be, it is minus 5. This will be minus 5. And if we are simplifying this completely, its value of the Vth, which is found to be, the value of the Vth which is found to be, this is minus 0.38. Means here its value is, it is 0.38 volt is the value of the Vth. And then we will try to find out the value of the Rth, that is Thevenin's equivalent resistance. Now what we will do, I will take out this terminal A outside and I will shift this terminal in such a way that it will be outside. Means what I will do, I will assume this is made up of, this thing is made up of the metal sheet, and here we have the screw. What I will do, this figure I will shift in the other direction, something like this, and then we are able to do the calculations. I will do its calculation later on. Now here figure will be something like this. Here is the A terminal, which is this. I am not doing for these two resistances, that is 10 ohm and 10 ohm will remain the same. Now here will be the 10 ohm resistance, which is same. Here is another 10 ohm resistance, which is also same. Something like this. This is 10 ohm, same. This is 10 ohm, same. Something like this. Now what I will do, I will shift this below. Means here, this source is a voltage source. And while calculating the value of the RTH, all sources are replaced by respective internal resistances. Internal resistance of this voltage source is 0. That's why we will replace it by 0 resistance. Then I will take this from outside. Means here, point B will come somewhere here. The point B will come somewhere here. This will be the point B. Now here, then this is, I will call it as another point. This is AB, this is AB, I will call it as C and D, and this will be the D point, and this will be the C point, C. Now D and B, we have 2 ohm resistance and 3 ohm. 2 ohm will be close to the D. Means here, this will be the 2 ohm resistance. Then this figure will be something like this. I will complete the figure and then we will go by the calculation. This will be the figure. This will be the figure. This is B terminal. Here this resistance is 2 ohm. This resistance is again 2 ohm. This is 4 ohm. Here it is 2 ohm. And this will be 3 ohm. Now here, if I am naming other points also, A, B, C, D, this will be E and this will be the F. Now look at D and E, here will be the E and this will be the F. Between D and B, we have 2 ohm. Then E and B, between E and B, we have another 3 ohm. C and F, we have 2 ohm. CF 2 ohm and finally and so on. Now this will be the next figure. Now here in this case again the calculation of resistance is somewhat difficult. There is no direct series and parallel combination. We have to remodify the circuit in the different way. Now what I will do, I will convert first this delta into star, this delta into star, and whenever we have the resistances internal side, something like this, in that case the calculation of the resistance will become very difficult. That's why I have modified this figure. I have not applied any formula, just modification of the figure is there. Then if we are converting this delta into its equivalent star, star will be something like this. I will complete the figure first and then I will work out on the calculations. Its figure will be something like this. This part remains the same. Here is A terminal. Here is one resistance which is of the 10 ohm. This will be the short circuit as it is. Here is one resistance. Here is another resistance, something like this. It is of 2 ohm, this is of 2 ohm, this is of 10 ohm, and this is again of 10 ohm. Now, these 3 resistances, 2 ohm, 4 ohm, and 3 ohm, will be replaced by another 3 ohm, which is star resistance. Here it will be one resistance, here this will be the second resistance, and here it will be the third resistance, and here will be the terminal B. We are interested in this calculation. R1, this is R2, and here this resistance will be the R3. I will do the calculation somewhere here. This is calculation of R1, which is equal to, this R1 means here is the R1. This is R1, it will be R2, this will be R3. This resistance R1 is the multiplication of 2 divided by summation of all. Means it is 2 into 4 divided by, it is 2 plus 4 plus 3, which is equal to. If I am doing this calculation, its resistance is found to be 0.88 ohm. I am using the calculator for this. You can use. Now R2, this resistance is R2. I will do the calculation for R2. somewhere here. This is R2 calculation. This resistance is R2. Means here in this figure it will be R2. How is the calculation? Multiplication of the two resistances divided by summation of all. Means 4 into 3 divided by 2 plus 4 plus 3, which is equal to. If we are doing that calculation 4 into 3 divided by 2 plus 4 plus 3, and if I am using the calculator, its value is found to be 1.33 ohm is the value of the resistance, which is R2. If we know R1, if we know R2, then we can find out the value of the resistance, which is R3. Somewhere, something like this, R3. Here is the R3. It is connected between these two. 3 into 2, this is 3 into 2 divided by 2 plus 4 plus 3. Because summation of all, which is very same as 0.66 ohm. This is 0.66 ohm is the value of the resistance, which is R3. Now everything is known to us. Now all resistances are known. Then we will look at for series and parallel combination. At the same time, look at this part. This is the short circuit. Its resistance is 0. In place of having something like this connection, we can do the connection something like this. Here, we can extend these two and we can bring something like this. This in place of using the long wire, we can use the short wire, which I will draw somewhere here, something like this. This is common point. This is common point. It is upward, it is upward. And now how is the remaining part? Here it will be the A resistance. I will draw in the systematic way. This calculation will become simple, or conversion will looks to be simple. This is 10 ohm. This is 10 ohm. Then here, this 2 ohm is in series with R1. These two are in series. Or I will complete the figure first. Here will be one resistance. Here will be the second. Similarly, here will be one resistance and this will be the second. Then we will come down and here will be the another resistance, which is R3, and this will be B terminal. The value of the R3 is 0.66, means this is 0.66 ohm. Value of the R2 is 1.33. This is 1.33. This 2 ohm, it is as it is. Then here, this 2 ohm as it is. This is R1, and the value of the R1, it is 0.88 ohm. This next figure will be something like this, and we can simplify this figure, and we are in a position to find out the value of the RTH. Missed here. The next figure I will draw somewhere here. Here is the A point. This is one resistance. This is second resistance. Then it will be one resistance, and this is another second resistance. Then I am going down. Here is the B terminal. Here 10 ohm, 10 ohm. I will put as it is. 10 ohm and 10 ohm. This is 2 and 0.88, means it will be 2.88. This 2 and 3, means it is 3.33. And here this resistance will be 0.6. And if I am working on that, its final figure is this. A terminal, this is B terminal. 5 is a parallel with 5, sorry, 10 is parallel with the 10, parallel combination is 5 ohm. Now, the 2.88 is a parallel with 2.33. I will do the calculation here. This is 2.88 into 3.33, which is equal to, divided by inside the bracket, 2.88 plus 3.33 close the bracket is equal to, this is 1.54. This is 1.54 and this is 0.6. Means RTH is found to be here, which is addition of the 3 plus it is 5 plus it is 0.6, which is 7.14. This is 7.14 ohm is the value of RTH. Now we know the two values. We know the value of the VTH and we know the value of the RTH. here, look at here, we have calculated Vth something like this, which is 0.33, and here we have calculated the Rth, which is something like this. Now we can use the step number 4. Now how will be the step number 4? Step number 4 will be something like this. This is step number 4. If we know the value of the Vth and Rth, then complicated network is replaced by the simple network, and which is known as a Thevenin's equivalent network. Its figure will be something like this. This is the final step here. This is Rth. Rth is 7.14 ohm. Vth is a 0.38 volt plus minus. And reconnect the load resistance which is removed in the first step, which is 50 ohm. Now we can find out this IL, that is load current here. What is the formula? IL, total voltage divided by total resistance. Or we can use the Thevenin's theorem, that is Vth, this is 0.38 divided by Rth plus RL, which is 7.14 plus it is 50, and its value is coming to be, this is 0.38 and this will be 57.14, which is equal to the final value of the load current. I will use the final calculator here. This will be, this is 0.38 divided by, this is 0.38 divided by, it is 57.14, and it is found to be 6.65. This is very same as 6.65 into 10 raised to the power of -3 amperes. Amperes is the value of the load current flowing through the circuit by using Thevenin's theorem. This is the calculation. That's all for this particular video. In this next video, I will discuss about how to do the calculation whenever we are using the Norton's theorem for the calculation of the current, and there is star and delta conversion while calculating the value of the Norton's resistance. That's all. Thank you.